So here we're going to look at an example where we'll look at the torque and initial angular acceleration applied due to weight. So I'm going to draw this rod first. So it's hanging horizontal. Initially is horizontal. And this is my pivot over here. And because it's a uniform rod, the center of mass is at its middle. So that's going to be 0.25 meters. The whole length here is 0.50 meters. And the mass is 1.5 kilograms. Okay, so the torque is the weight applied at its center of mass. So the force is mg. So that's 1.5 times 9.80. Okay. So that's going to be 15. So that's going to be 14.7 newtons. Now, if I do this, I then find the torque by applying the distance times that. Now, initially, you could note that this point, because it's horizontal, this perpendicular distance over here is 0.25. So that ends up being 3.68 Newton meters. Now, to find the initial angular acceleration, I need to use the moment of inertia. Remember, tau is I alpha. The moment of inertia is that of a long uniform rod from one end. So it is 1/3 mr squared. Make sure, or more precisely, or actually 1/3 ml squared. Where's my? Okay. So 1/3 ml squared. I'll just erase this out now. So if it's 1/3 ml squared, 1/3 times the mass, which we know is 1.5 kilograms. L here is 0.5 meters. And this turns out to be 0.125 kilogram meters squared. So therefore, if I plug this back in, 3.68 is my torque, is 0.125 times the angular acceleration. The angular acceleration is therefore 3.68 divided by 0.125 is 29.4 radians per second squared.